everyone, it's Mr. Do the Math here. Today we're going to talk about multiplication and division properties. Alright, proofs 2.6. Alright, with multiplication and division properties, what we're thinking about is three legit key terms. That is bisect. What's bisect mean?
Dividing the two equal parts.
Divide by two, right. That's trisect. What's that mean?
Divide by three.
By three. And midpoint. What's that mean? By two, right. So it's to divide and multiply by two, divide and multiply by three, divide and multiply by two again, right? These are our signs of multiplication or division when you talk about the frameworks of geometry and in the sense of proofs, right? And so today we're going to look at how to write proofs dealing with multiplication and division properties, all right? Identifying multiplication and division properties. So let's look at this problem here. So we got two segments. Bop, bop, bop. All right, so give me some letters. I need 4 letters. A, B, C, D. Whatever. Give me 4 letters.
I-A-N-K.
L-M-N-O. All right, L-M-N-O. All right, this is the given information. All right, given. All right, where we put given at? All right, so we'll put it here. Given. Our given information is that B, C, M, and N are trisecting points. Are trisecting points, right? What kind of conclusion can you draw about this figure here? If bam, bam, bop, bop are trisecting points. What all things can you draw? Yes, Matt.
They're all congruent.
Who is all in they?
A, B, B, C, C.
Bop, bop, bop. Right, they're all congruent, right? What else can you draw? Yes,
L, M, M, N, and N-O are congruent.
they're all congruent as well. Now, in your given, what if they said this? They said that AD was congruent to LO. Now, how do you change the information that you have here in these two pictures? What can you say? So, like we said, these are congruent, and we said these are congruent. Now, because this whole segment is congruent to that whole segment, these markers need to be the same, right? Because they're the same length. Y'all follow me? Mm-hmm. Right? What if they said this? AB equal 3, right? AB equal 3. Yes, sir.
Would that mean all segments equal 3?
Everybody else equals 3 as well. Yes. Right? So now, this is an example of division, right? If they said AD is congruent to LO. If AD is congruent to LO, and these are all trisecting points, that means that between these two segments, you have 2 pairs of 3 congruent segments. So AB is going to be congruent to LM, which is going to be congruent to BC, which is going to be congruent to MN, which is going to be congruent to the last 2, right? Everybody follow me? All right? What's the key term in all of this given information? Trisect is the key term, right? Cool. Let's look at angles. Let's look at some angles. All right, let's look at some angles. What if I have bop, 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 bop? All right, give me 4 letters.
I-A-N-K.
I-A-N what?
K.
K. All right. And then give me another set of 4 letters.
T-R-E-Y.
T-R-E-Y. All right. There we go. This is a very narcissistic angle. Both of them. All right. So, if AK bisects angle IAN and RY bisects TRE, I'll check that out. It's cool, huh? All right. What conclusions can you draw? What do you see? What do you see? What do you see? What do you see? If this bisects and that bisects, what can you say about this? Yes, Josh.
That the angles are congruent.
Which angles are congruent?
IAK and TRY.
TRY? Yeah, I mean, but we didn't say that yet. What can you say about each individual angle?
IAK is congruent to KAN.
Yeah, these two are congruent. Because they're bisect. Bisect means to divide by 2, right? Now, in the given there, also say something like, they might say this. What if they said IAK is congruent to angle TRY? Do that. Another word. All right. Now, if they say this, now what do you see? Now, what conclusion can you draw? All right, tell your shadow partner what conclusion you can draw.
IAN is congruent to
All of them are congruent.
All right, Charles, what did you say again?
I said IAN is congruent to TRE.
IAN is congruent to who?
TRE.
Trey, right? Why? All right, great. It's a great question. Why? Why? Why do you think? Why do you think? Why do you think? What can you say about it? Trey, can you say something about it? This is your angle. Matthew, what you thinking? You thinking? Was you gonna say something?
No.
All right, Trey. Okay, well, check this out. You guys said that, well, we said that this angle is congruent to this angle, right? We also said that this bisected this angle and this bisected this angle, right? So if these are bisected, that means both of these angles are congruent, right? And these angles are congruent. But because these two angles are congruent, these two angles are going to be congruent. And when you add these together, this whole angle is congruent to that whole angle, right? Which leads us to our new theorems. If you got your green papers, at least you have your new theorems, Theorem 14 and Theorem 15, right? Theorem 14 says that if segments and angles are congruent, they're like multiples of congruent, right? So, if segments or angles are congruent, then they're like multiples are congruent. All right? Like multiples meaning bisect, trisect, or midpoint, right? And theorem 15 says if segments and angles are congruent, then they're like division are congruent, right? That goes here. And we're talking about trisect, bisect, and midpoint, okay? Now, how do we identify those things? How do we know that we have division or multiplication property? All right, there's two things to look for that's in the phase of 3. All right, the first thing you want to look for is use of double words, right? Use of a word twice. All right, in this case, the double words are going to be our multiplication or division words, i.e. trisect, if I spell trisect right, bisect, and midpoint. That's the first thing you look for. When you see that, we're dealing with either multiplication or division property, right? The second thing you want to look for is you want to look at your givens, right? Look at your givens, right? If the given is larger than the proof, right, or your conclusion, if the given is larger than the proof, that means that's division, right? That means you went from big to small. Big to small, that's division, right? If I cut this in, if I bisect this or cut this in half, it went from big to small. I divided it, right? Or you're gonna look at, so this is 2A, this is 2B, right? Let's look at it this way. If the givens small, then if the given small and the proof statement is big, right? So if the given smaller than the proof, then we have multiplication. All right, so let's go back here, right? So in this particular situation, we had, in our givens, this was trisected, right? You had two pair of trisecting points, bop, 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 right? And then it said AD is congruent to LO. AD is congruent to LO. This is in a given, right? This is an example of the big part, right? And then you have to prove that BC and MN are congruent. So you went from big to small. This would end up in division property, right? Now in this case, this said IAK small is congruent to tri, right? These are small. You went from small to prove that this is congruent. That would be multiplication, okay? That would be multiplication, okay? We good so far. How we feeling? Y'all waiting to see what's gonna happen? Yeah, okay, here we go. Let's do a proof. All right, here we go. Let's do a proof. Let's do a proof. Here we go, here we go. All right. I should have left that. I'm gonna leave that there. All right, theorem. This is theorem 14 and 15. All right, so you got this line here. You got line segments. Line segments, MOP, and NRS. NRS. All right. Given information. MP is congruent to NS. Right? Then it says O is a midpoint. And it says R is a midpoint. Right? You have to prove that MO is congruent to NR, I believe. All right, so first things first, let's look at our given information. Our given information. MP is congruent to NS. Is MP and NS big or small?
Big.
Huh?
Big.
It's big, right? Do we have double words here?
Midpoint.
Yes, midpoint is our double word. We've seen it twice. So we're gonna have either multiplication or division. Now it's going big to MO. MO's big or small?
Small.
Small. MO and NR, they're both small. So we went from big to small, right? So we're going from big to small, which means we're doing division property, okay? Now let's do it let's write our proof out of it. We don't need a lot of space because it's straightforward. So we got statements, reason. First part is we got MP congruent to NS, given. We got O, I'm gonna just abbreviate this, O and R are midpoints, right? That's also given. All right. Then from here, we got, all right, these are congruent, these are midpoints, which means this, right? So because these are midpoints and we know these are congruent, then we can just go straight to our final thing is MO is congruent to NR. Why? Because if segments are congruent, then their like divisions are congruent. So you could just write division property. That's it. That's not too painful, is it? All right. All right. Let's go to a more challenging one, right? All right. Well, let's go to a slightly more challenging one. So we're gonna come over here. All right. We got this shape here. What kind of shape is this? A rectangle?
No.
What is it? A parallelogram? You think?
Polygon.
Okay. Trey said it? I think Josiah said it. Alright. Here's the given information. Alright. MK is congruent to FG. Then it says that KG bisects MJ and FH. Alright? You gotta prove that MJ is congruent to FH. Alright? So, MKFG, big, small.
Small.
It's small. What's your double use of words? It's gonna be bisect because it's referencing two segments, right? It's bisect because it's referencing two segments, right? Thanks. Appreciate it. Snazzy shirt you got there. Thank you. You're welcome. All right, bisect. That's our key term. Now, MJ and FH, is that big or small?
Big.
Huh?
Big.
Big.
It's big, right? What's up, man? How you doing?
Good, how are you?
Great, great, great.
I'm sorry to interrupt your class.
That's all right. Thank you. I appreciate that. How long you gonna be around?
A week to maybe a month, and then I go back to California for more training.
Okay, so after class, you're gonna have to take a picture.
Okay.
I'm proud of you. You look good, man.
Thank you.
Cool. All
I'll
right.
see you later.
All right, buddy. So, small to big. What's that gonna be? Multiplication. All right, so let's write this proof out. Given. All right, so statement, reason. Right? What's our first statement? MK is congruent to FG, right? Then we're gonna say KG bisects MJ and FH, right? Given information. Do we need any more information? All right, let's make sense of this. All right, so make sense of this. MKFG congruent. MKFG are congruent. They said this bisected. So because this bisected, that meant that both of these are going to be congruent, right? And so if these two are congruent, and this cuts both of these in half, and these are already congruent, then all of this, when you add this together or you multiply this by 2, you get the same thing for both of these, okay? So then MJ is congruent to FH. Why? We went from small to big. Multiplication property. Okay. How are we feeling so far? It's simple, right? It's not. There's nothing more to it. It's it. Now, what if we add like another thing to it, though? You want to add something else to it? I mean, but you're gonna have homework that looks like it, or you just want to just deal with just this. You don't want to look at a homework problem.
Put like one homework problem so we know what we get into.
You want to know what you're getting into?
Just one. Don't look at me like that.
All right. So I mean, but in the framework of multiplication and division property, this is it, right? When you see doubles somewhere, we just dealt with midpoint in our example proofs, right? Then you're going to have multiplication and division property. You want to look for the use of double words. You want to look at what the givens look like. If they're bigger than what you're proving, right? If they're bigger than what you're proving, you're going to divide. If they're smaller than what you're proving, then you're going to multiply, okay? And so that is multiplication and division properties, all right? Have any questions, comment below. Don't forget to like and subscribe. MrDoTheMath out.